Hello, everyone. It's gonna be a lightning talk, so I'm just going to touch on one topic and go deeply on one simple thing. Let's hack the tools. So, what to do when you don't know how to debug things? Like you run out of any ideas and you're frustrated. And I just want to highlight you yet another tool for you to use in your toolbox when you run out of ideas of how to know what's happening under the hood in your Flutter tooling. So let's hack the tools. I'm Mateusz. I'm head of mobile at LeanCode. Been developing apps for about 10 years right now. I'm also Google developer expert for Flutter and Dart. And I'm from LeanCode. It's a Flutter expert studio from Warsaw, Poland. We are known for Flutter Enterprise. And from these projects, actually, from the banking app for Crédit Agricole, I came up with the idea of hacking the tools. And this was the first use case that led me into this presentation. So let's start. What is this all about? So sometimes you have these situations when the debugging is not enough because debugging is in the runtime and in your code. And sometimes you see this code and yet still you have some unexpected behavior that you think might come from the tooling itself, or that you don't understand exactly what the tooling is doing under the hood with your code. It can happen to all of us. There are some situations when you think, okay, I don't know. I just don't know. And even the worst thing is you don't know where to look, because someone could tell you, okay, there's an issue about it on Flutter repository, right? But how would I know which issue is actually impacting me right now? So, for example, you might have some build errors or tooling errors that make no sense, or you want to do something that's not an official way of doing things. Like, for example, Flutter does it in the XYZ way, but I don't want it to do it that way. Today, I want to change it a bit and see how it actually works under the hood. So this is very much referring to the keynote that was today from Kevin, because he mentioned changing your Flutter SDK locally. So this is exactly what we'll be doing today. So let's have an example. It's a real life example. In one enterprise project, we had some complex add-to-app environment when they used Flutter in add-to-app in other native apps, and they had some Flutter plugins, and they compiled Flutter as framework on iOS and AIR on Android, and they were using Dart defines to pass some configuration, but they were altering it in some different environments. In production was something different. They used Dart defines from file, but also Dart defines from CLI and so on. And they asked me that what's happening, like it's not working for us, and what's not working for no, like they said, okay, this is not working because like the whole Dart defines should look different, and we expect some different behavior. Okay, we don't know what's happening. And then you might think, oh, if I only could see what Flutter tooling can see under the hood, what's the Dart define for them, for the tooling, what's building inside. So actually, we can see that. We can alter the SDK the way that we can see. So what's essential in today's talk is Flutter Tools. Flutter Tools is the package inside your Flutter SDK. So when you install Flutter on your computer, or you use FVM, Flutter Version Manager like me, and use some Flutter SDK version, you download all the Flutter repository on your computer. And also within this Flutter repository, you can see a directory called packages, and inside you have multiple packages like Flutter itself, which is compiled within your app, but also Flutter Tools. Flutter Tools is a package that, how it's stated in the README, it contains CLI, like command line developer tools for building Flutter apps. So every time you use Flutter commands on your computer, it's actually this code that's executed. So in our Finder, when you go, like, here is my path for Flutter SDK with some version in FVM, and you can see we have a packages directory, and then we have Flutter tools directory. All right, so let's try it out. Let's print all Dart defines. Let's change the Flutter tools so that we can see all the Dart defines printed every time we run the Flutter command. Maybe it will help us. This is, some print debugging stuff. Like we are out of ideas. Let's see what Flutter tools are seeing under the hood. Okay, so I have the app right here, some example app. And if I just run Flutter build APK with, let's have this Dart defines, right? And for example, I have a Dart define. Let's build it. Dart define from CLI, which is CLI equals true, and also from end.json. End.json has some two Dart defines and also CLI set to false. And I don't know which superseded by which one. I don't know. Actually, I don't know what happens, and I want to see all the Dart defines printed. Of course, if I do it right now, I can see it got printed. But why it got printed? This is a very, very important place, because actually I messed up a bit. Sorry, because this is my Dart SDK. This is my Flutter SDK. And here I found in my Flutter tools package, I found Flutter command.dart. And here is a function called getBuildInfo. And I found that here all the Dart defines are being passed to the build. So okay, I can change this line and just run it, right? So typically, when I just build the SDK, let's see right now. So when I do Flutter build APK, so when I run Flutter for the first time, you will see something called building Flutter tool, right? This is only seen for the first time. So now I simulated the situation when I have my Flutter run for the first time. And as you can see in here, you cannot see anything about Dart defines. Here I had a version from before the talk when I tried it out. Sorry, a bit of spoiler. But now when I ran it, I have no information. So I have no Dart define. And even if I uncomment this line and I save the file and it should print, when I run it again, it won't get printed. So you might think, okay, I changed the file, but nothing works. So why it's not working? This is very important. It's because the first time we run Flutter, the code that I mentioned within Flutter tools, it gets compiled. It gets built for the first time so that it's cached already on your computer. It makes a lot of sense because this is not supposed to be changed on a normal basis. So there's no use in recompiling it all again and again and again. So if you go to your SDK directory and you have your bin directory, then you have cache directory. Inside cache directory, you can see a lot of Flutter-related files. And two of those are important today, fluttertools.snapshot and fluttertools.stamp. So fluttertools.snapshot, which as you can see is like 40 megabytes, this is the actual binary. The actual binary that is built from the code you've seen. So the package Flutter tools on your computer will get built into this snapshot file. And the stamp is something for the cache, from the caching perspective to just do the hash of your code. But these two files are essential because Flutter SDK, like Flutter tooling, looks for them, and if they exist, it won't recompile. So you have to delete them because snapshot is being built once, right? So we want to achieve this situation when it's building Flutter tool when you run the command. So because if you can see building Flutter tool, you know that is exactly from the code that's on your computer. So how to achieve that? We can go to our Flutter SDK root, and here we can see the bin directory, cache directory, right? And here you can see fluttertools.snapshot and fluttertools.stamp. So this is actually just a hash, as you can see, and this is a binary. So let's delete both of them. I deleted the files. I uncommented this line, so the Dart define should be there, even to check if it's not cached. Welcome Fluttercon EU 25 or something like that. And let's do that. I save the file. I'm coming to my example, and I'm running Flutter build APK again. And you can see this building Flutter tool. This is very important, right? So this building Flutter tool means that it actually got rebuilt. And now we can see welcome Fluttercon, and we can also see our Dart defines. And from our Dart defines, we can see that this array is being assembled from both arguments from the Dart define CLI and Dart define from file. So as you can see, first are the Dart defines from file, and they are superseded by Dart defines from CLI. So I know, even if it was not documented in the official Flutter docs or anything, I can just see how it works on my computer. This is very important because it gives us much deeper knowledge and sense of how things work under the hood. So if you have any idea of, okay, I would like to see how it works, I would like to see more verbosity, more printing, more information of how it works under the hood, you can always do that. It's only on your computer. You are one step away. You just delete the file, and you can just do whatever you want in your own code. So you might ask, okay, great fun fact, bro, but what's the use case for that? And actually, there are multiple use cases. Like in my history, there were multiple use cases for that. So first one was generating obfuscation maps with production builds. So who here used Dart obfuscate flag? Great. So when you run production builds, not so many of you, maybe you should in production, by the way, but in production builds, you might want to obfuscate your builds, especially when you are in some regulated environment, which tells you so. Like, for example, we did a banking app, and in Poland, when you do banking apps, you have to have some security standards checked and verified, and one of those is code obfuscation. You have to obfuscate your code in production. So we ran Dart obfuscate, like you can do -- obfuscate, and it just works, right? Yeah, it works, but then you can see in your Crashlytics or any other tool, you can see something like this. This is the obfuscated Flutter crash. And everything from the 0, line, it's just obfuscated stack trace. So you can see, like in the stack trace, you can see the methods that were sequentially executed. So there's official way of doing it and like symbolizing it. It's called Flutter symbolize. So when you run Flutter command with split debug info, you get this debug info directory with all the information needed for Flutter symbolize command, and then the stack trace is cool. Okay, the stack trace is cool, but still we have the first line of our code of our crash, which is the actual like string information of the exception, which is the message, and its type int is not a subtype of type CA. So what's CA? There is no such type of as CA in our code. This is because when you obfuscate code, all the classes get different names. But when you use Flutter symbolize, you don't get those names. You only get the stack trace. So we had some situations, which is the real use case from the bank, when we had crashes from production and we had this type error, for example. Integer is not a subtype of CA, and we don't know what's CA, so we cannot actually, the stack trace is not enough sometimes. So we thought, okay, there must be some way of getting those information, because the Dart compiler has to get this, generate this map. So back in the days, there was no information about it in Flutter documentation. Now it's better, but it was, I think, 2021 or 2022 early. And we found in Dart documentation that there's, inside Dart code, there's a comment about it, which is that when you use obfuscate, mapping between original and obfuscated names can be serialized as a JSON array using safe obfuscation map option. So it got us idea that if in our Flutter SDK there's some usage of gen snapshot, which has to be there because you compile Dart code, somewhere in the Flutter tools has to be the command that invokes the Dart compiler and actually compiles the code. And if we can get there and just pass one more flag, then we're golden. Then we have that array. Since we have the JSON file, we can do anything. So then we found out, because we read the Flutter tools code, that there's another flag that's called extra gen snapshot options. So it looked like the flag that was created for us, like literally. Like extra gen snapshot options is the thing that we were looking for. We wanted just to literally to add another flag. And it's something that's not so much documented, I think still, because yesterday I tried looking for it. And when I used Flutter help or something like that, it's not there. You have to do verbose help or something like that to see that in the Flutter CLI. So then we added the extra gen snapshot option, and we got something that's described in here. Because right now in the Flutter docs, for about 2 years, from what I checked, you can already see the actual extra gen snapshot option with this safe obfuscation map info, which is very important. But then we didn't know what to do, and we just were trying to find it in the Flutter tools. That's the one use case when it really helped us. So these are such hardcore situations when you just want to know what's happening under the hood. So this is the example of this map. As you can see, the material app is the real type, EX is the obfuscated type, scaffold is the real type, EY is the obfuscated type. It's not even the map, it's just the array. So it's even less intuitive. So right now you can use this in your code. And for example, with this CA, I also tried it. So here, there's something like a CA, and it's actually pattern. So it now makes sense that the type is pattern, because this is the place I used to generate this crash. I just used a contains method on string, which takes a pattern and used a dynamic, which is integer. The easiest way of generating some type error is just to use dynamic, right? This is literally why you use dynamic to mess with the types. And it's actually true, the pattern is CA. So this is the one scenario. Some things are not documented yet. Of course, nothing is, nothing is 100% documented. So this is one use case when we needed that. Another use case that we needed that, who knows Patrol, the package for automating tests. Okay, great. I can see a lot of hands. So we are the creators of Patrol. And when we were doing Patrol, a couple months ago, we had an issue where someone told us that from a new version of Flutter, like 3.30 or something like that, Patrol freezed on Android when was ran with profile or release flag. So some people, usually you use tests with debug mode, but some people use that for performance testing, stuff like that. So they use profile mode or release mode. And we had now deleted code because we had to do an emergency change, but we had patrol plugin.kt, which is when you use plugins, you have a native file for a plugin, patrol plugin kt, patrol plugin.swift, and this is the Kotlin plugin. So we had this code that was activity aware. So when we started the patrol server, you started patrol testing, we got attached to the activity, and we ran some code that was initialization logic. So we thought, okay, it means that this code is not executed. Why is this code not executed? So it should be because it's in Patrol plugin. So we added a lot of prints in Patrol plugin. None of these prints were actually hit. So any prints were not hit. We didn't see anything. We didn't know what's actually happening. So okay, then we saw that when you use Flutter pub-get or any Flutter build command, you actually generate something called generated plugin registrant. So we saw that in this generated plugin registrant, it got changed when we changed the debug to release and so forth. So we found a method in Flutter tools, which is write Android plugin registrant, which literally takes all the Android plugins to write there. So we printed all the Android plugins. And when we printed all the Android plugins, and use that within debug. As you can see in here, this is the same app. We could do that in a minute. So Firebase, 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 and Patrol. Everything seems to be good. And it also worked with debug. But then we ran release and profile, and we saw Firebase, 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 period. We cannot see Patrol. So that gave us a hunch, okay, so our code is actually not even compiled. That's why any of the prints are not working, because there's no such code inside our app. So then, thanks to that, we found an issue that's actually there in the Flutter repository, that there was an issue that the plugins that are from dev dependencies were not stripped in release. So it was a kind of a side effect that it worked for some of our users on release and profile. It was not the official way of using Patrol, but we knew that some of our users use that in profile and release, and it just stopped working. So it was actually the bug that they fixed, and it introduced a bug for our users. But thanks to that method, we knew that the exact, what's the thing that's happening under the hood is that our plugins are not compiled. So then we have a better thing to Google, the better thing to type in the GitHub issue search bar, so we can find it. So this is another use case that helped us, that this method helped us. So another thing is that, like, the last thing I want to say is that this is just yet another tool in your toolbox. So this is not anything that is helpful inherently, like it solves your problems. Not at all. It's just like, debugger, logger, you have Sentry, I don't know, you have other SDKs, you have printing, the best way, of course. And then maybe this is still not enough. And you might need changing your Flutter SDK, because you can either change your Flutter SDK, which is the package Flutter, literal package Flutter, which is not Flutter tools, but Flutter. And this is the thing that's compiled, like, all the material widgets, all the framework that is compiled within your app. But maybe the tooling is something that you want to alter. So this is also important when you want to learn more about how Flutter works under the hood. If you want to start contributing, if you want to know how things are working because you want to maybe change them, or maybe something you don't like about Flutter tooling and you would like to know more about how it works. So this is just yet another tool for you to know better what's happening in your code, because I'm one of those people in the development when I hate when I don't understand. I hate it so much when something happens and I don't know why. This is frustrating. So that's why I use things like this. Maybe it sounds extreme to you. Not for me at all, because I just want to know. I'm dying to know what's actually happening with my code and why our package is not working for some people. This is very frustrating. So yeah, thank you very much. Last thing, I'm from LeanCode. And you can find us if you have any questions, and this time for the questions is not enough. I'm here, of course, with the whole LeanCode team until Friday, and you can meet me at our booth. We are doing two things. One is migration to Flutter, the ultimate guide, which is if you are doing Flutter as your side project, and for example, you cannot convince your manager to switch to Flutter. I know that many of you have this problem because I talked to you about it. This is one of these ebooks that can help you convince people to how to migrate to Flutter. And another thing is that we are very much experimenting with using AI-assisted coding, and we also have our AI-assisted coding stack on the booth, and we are very interested in your feedback and what you're gonna say about it. Thank you again, and I hope you're gonna mess around with the Flutter tools on your computer.